Hi, Assalamualaikum and hello to Dr. Arif. My name is Ahmad Afif Jazimi bin Kashii and we are from Group 1 of this course Thermodynamics and Mechanics of Material Laboratory. So our group consists of me, Lim Kai Peng, Lau Jiru and Muhammad Nazri. So today we will present about the experiment 1 which is a Marcet boiler. The first part is introduction. In this part, I will focus to objective and scope. The objective of this experiment is to observe the relationship between the pressure and temperature for saturated steam. The scope of this experiment are: this experiment is conducted under ideal gas behavior, like gas particles have perfect elastic collision with no energy loss. The volume of gas particle is negligible, and gas particles do not have intermolecular force with other gas particles. Number 2, the Marcet boiler assumes pure steam, so the pressure must be in absolute terms. Number 3 is distilled water is used in this experiment instead of tap water. And number 4, the Marcet boiler's temperature change are not average 0.5 bar increase up to 5 bars during the increasing pressure and then decrease from 5 bars during the decreasing pressure.
So next I will introduce about the theory of this experiment. A Marcet boiler experiment is a simple experiment to show that the relationship between the pressure and the temperature of the saturated steam for the comparison with published result. The energy within water increase, so the molecules activity will also increase, and thus the number of molecules escape from the water surface also increase until the equilibrium state is reached. This equilibrium state depends on the pressure between the water surface and steam. At lower pressure, less energy required in achieving the equilibrium state, which is boiling point, so the molecule become easier to leaving the water surface, which means that the lower the pressure, the lower the temperature for saturated steam. Saturated temperature is the temperature where the equilibrium occurs at a given pressure level. This is the Clausius-Clapeyron equation that we will apply in this experiment, where Bf is the volume of water, Bg is volume of steam, Hs is enthalpy of water, Hg is enthalpy of steam, and Hfg equals to Hg minus Hf, which means heat domain of vaporization.
The next part is experimental setup. As you can see in the figure 1 is a Marcet boiler and that's how it looks. And the figure 2 is the part of apparatus in a Marcet boiler. In this table, I will show the part of apparatus in a Marcet boiler and the name of that part of apparatus. Number 1 is drain valve. Number 2 is heater. Number 3 is overflow valve. Number 4 is filler plug. Number 5 is safety valve. Number 6 is temperature sensor. Number 7 is manometer. Number 8 is boiler with insulating jacket. Number 9 is temperature gauge. Number 10 is heater switch. And number 11 is master switch.
Step 1. Distilled water was used to fill the boiler through the filler plug. Step 2. The overflow valve was opened to let the water flow out when it's full. Step 3. Filler plug was closed by using a spanner. Step 4. The boiler was heated until it reached 97 degrees Celsius. The overflow valve was then closed. Step 5. The temperature was recorded for every 0.5 bar increase in pressure until it reached 5.0 bar. The final step, the heating was switched off and the temperature decrease for each 0.5 bar was recorded.
The table shown in this section is the result of our group obtained from the experiment, as we can see that the temperature for both the increasing and decreasing pressure have increased. To complete the table, the measured slope and calculated slope will be determined as follows. We first apply the Clapeyron equation to convert both the pressure and temperature unit to SI unit. To convert SI unit for pressure, we can multiply 100 to convert the value of X bar to the value of X kilopascal. To convert SI unit for temperature, we add 273.15 degrees Celsius with another value of X degrees Celsius to obtain a value of X Kelvin. The table shown in this section represents the converted unit for absolute pressure, temperature for both the heating and cooling process, and the average temperature. After the units are converted, the graph of absolute pressure against temperature for both heating and cooling process are sketched in one graph. As you can see, the red line represents the heating process and the blue line represents the cooling process. From the graph, we can see that when the temperature increases, the pressure increases for both the heating and cooling process. Another graph of absolute pressure against mean temperature is sketched for the objective to determine the measured slope. This graph also shows the same result as previous graph, the pressure varied with temperature. To complete the data sheet, the measured slope dt over dp need to be obtained from the graph as shown previously. However, the slope obtained from the graph is dp over dt. Hence, we need to do some modification to obtain dt over dp. As stated at right side, first the value of dp over dt is obtained. Then, take 1 divide the slope. Now we can get dt over dp. Here is a simple example on how to determine the measured slope. We take two rows of data. The second row will minus the first row data to get our dp and dt. You may pause the video to look through the steps. This section shows the summary of measured slope. From graph 2, it yields the data as shown at right side. Once again, you may pause the video to look through the data. Next, we will determine the calculated slope by referring the table 1 as shown at left side and substitute the values into the formula of the calculated slope. Before we substitute any values into the formula, we first convert the unit of pressure and temperature into SI unit. Followed by that, the missing value of specific volume and enthalpy for all the pressure values with multiple of 0.5 will be determined by interpolation. Lastly, substitutes all the required values into the formula. The table shown below is the summary of table for the range of calculated slope. Again, you may pause this video to look through the data. After we obtain the measure and calculated slope, we fill in all the values into the data table. As you can see, there is no value at the last row for measure slope. This is because measure slope can only be obtained with two ascending points. This section is the discussion for this experiment. A short revise on the objective of this experiment is to determine the relationship between pressure and temperature for saturated steam. The initial condition in this experiment for the temperature is at room temperature and the pressure is at 0. There are a few things we have observed from this experiment. First of all, from the graphs, we can see that the pressure varied with temperature. This indicates the relationship between the temperature and pressure is directly proportional. The reason we need to find measured slope is because it represents the observed relationship between pressure and temperature, while for the calculated slope, it's simply because it represents the theoretical relationship predicted by thermodynamic principle. From the result we obtain, the measured slope and calculated slope are closely matched. This shows that the experiment data highly aligns with thermodynamic principles like the ideal gas law, PV equals to nRT.
The result table and the plotted graph of pressure against temperature, the measured slope is slightly different with the calculated slope. This might be caused by several errors occur during the experiment. This experiment is considered success as the deviation value between the measured slope and the calculated slope is less than 0.06. From the experiment, we could know that pressure and temperature are interdependent. The saturated steam temperature is proportional to the pressure. The pressure increases as the temperature increases, and vice versa. To improve the accuracy of the result obtained from the experiment, first, the reading of the pressure gauge should be taken at the eye level that is perpendicular to our eyes to avoid parallax error. Secondly, the reading of the temperature should be recorded after the pressure was stable. Furthermore, air must be completely removed from the bath by closing overflow bath when the temperature is around 97 degrees Celsius to 100 degrees Celsius to avoid any inaccuracy of the readings.
Last part is safety procedures. The first one is personal protective equipment PPE. The students need to wear appropriate PPE for experiment and wear a closed-toe shoe. The second one is handle the apparatus carefully. This one need to avoid from breaking any apparatus, avoid missing any apparatus, and the students need to report to lab assistant if thermometer is broken. The third one is report any injury. The students need to report to lab assistant to get first aid treatment if anything happens. Number 4 is do not touch the Marcet boiler when the experiment begins to avoid playing around with hot water. And the last one is tidy up. The students need to clean the work area of experiment and return all equipment and apparatus to designated place.
These are the reference that we use to refer for this experiment. This is the appendix of our experiment.